Good morning, ladies and gentlemen. I'm sorry I couldn't be there for class today, but something unexpected came up. Anyway, so what we're going to do today is I'm going to teach you the lesson through this video, and then I want you to take notes on it just like you would for class normally. And then when it says to pause the video, I want you to pause the video because I'm going to have you answer a question on your own to make sure you understand the material. Alright, so let's get started. So we've been talking about percent and interest this chapter. Yesterday we did simple interest, so today we're going to do compound interest. And the way that they're different is simple interest is you're only gaining interest on the money that you deposited into your account. But compound interest is you're gaining interest not only on the money that you deposited, but also the interest that you've previously earned. So compound interest, you earn money more quickly. Alright, so we're going to start. I'm going to tell you what the compound interest formula is because handy dandy formulas are always good to have. So if you deposit dollars at a rate R, and we always write R in decimal form, subject to compounded interest, then an amount A, that's our future value, occurs after T years. So here's our formula. A equals P times 1 plus R raised to the power of T. So this is very similar to our simple interest formula, our future value formula, except the T now, instead of being multiplied to your rate, is our exponent of 1 plus our rate. Alright, so here we go. You deposit $2,000 in a savings account at Hometown Bank and has a rate of 6%. So we're going to determine our future value. So first thing we're going to do is we're going to plug in. And let's see. The $2,000 is our principal amount because that's how much we're investing. And then the 6% goes in as our rate. But what do we have to do with percents? We have to write it as a decimal, so we're going to change it to 0.06. And then it doesn't tell us how many years, so let's just assume it's after 1 year. So we're going to plug it in. Our future value, A equals our principal amount, $2,000, times 1 plus 0.06 raised to the power of 1. So after 1 year. So order of operations says we do what's in parentheses first, so we're going to add these together. Okay, and then order of operations says we do exponents next, so I have 1.06 to the power of 1 is just 1.06. So I'm going to take $2,000 times 1.06. I'm going to do that on my calculator real quick. And we get a total of $2,120. Oh, hey, look, this one says do it for 3 years. So if you did it for 3 years, you'd have another couple $100. So why don't you go ahead and write down both of those, that way you can see with one and with more than one. And then we can find out how much interest we earn by taking how much money we made after 3 years and subtracting our initial investment. So we made almost $400 in 3 years. And that's money that you put in the bank and you leave and you don't touch. Alright, so go ahead and pause the video really quick. I want you to answer this one, do it on your own, and then I will also put the answer on here, but that's why I want you to pause it now. Alright, so here I've worked out the problem for you, so you can see where you plug stuff in, and then how you simplify, and you should have gotten $1,216.65. Alright, for our next example that we're looking at, it's more the compound formula, and our formula is very similar, except if you have interest that's instead of compounded yearly, if it's compounded monthly or compounded quarterly, then what happens is there's a different formula that you use because that means the compounding happens more often, which means you make more money. So the formula for that one is this right here. The only difference is you're going to take R and divide it by N, and then you're going to take T and divide it by N. And then N stands for the number of times it's compounded in a year. So if it's compounded yearly, then N equals 1. If it's compounded quarterly, I think I can spell, then n equals 4. If it's compounded monthly, we have 12 months in a year, so n equals 12. If it's compounded weekly, that'd be cool. There are 52 weeks in a year. Or there are even some that are compounded daily, and that would be 365. But I think your book, for the most part, at least when you do Math Excel, it'll have you use 360 days in a year. I don't know why they do that. They just do. So anyway, so make sure you make a note of that. N stands for the number of times it's compounded. Alright, so you deposit $7,500 in a savings account that has a rate of 6%, and the interest is compounded monthly. So we're going to find our future value. So the first thing we're going to do is we're going to put it in our formula. So A is our future value that we don't know. The $7,500 is our principal. That's how much we're investing. 6% is our rate, and then it's compounded monthly. So that means n equals 12 because there are 12 months in a year. And then it doesn't say how many years. One moment. Okay, we're going to assume that our time is 5 years. So let's go ahead and plug all that in. A equals 7,500, how much we originally invested, times 1 plus our rate is 0.06, divided by our 12 times it's compounded in a year, raised to the power of 12 times 5. Okay, so we're going to do some calculating. 0.06 divided by 12 is 0.005. So I'm going to go ahead and write that as 1.005. And then 12 times 5 is 60. So I'm going to go ahead and put that up here. So that's just simplifying it there. Use your order of operations, multiply this first, but it's going to be some long messy number, and then multiply it times your 7,500. And then I'm going to go ahead and put that answer right here after I plug it into my calculator. Okay, and you should get $10,116.38. So that's a bit of money. That's pretty cool. Alright, let's see if we got it right. We sure did. And then to find the interest that you made after that 5 years, you go ahead and take that amount that you have, your future value, subtract your original investment of $7,500, and you made, $2,000, $2,600, even better. Alright, I've got one last one for you to try, so why don't you go ahead and pause the video, and then go ahead and work this one out really quick, and then I'll put the answer up here too, but make sure you pause it. Alright, so here I've worked out the problem. So it has, let me pick a different color here so I can circle things. Here we go. So when you simplify, you find out that at the end of the 10 years, excuse me, you have a little over $6,000 in your account. That's money that you haven't touched for 10 years, which is pretty cool. You haven't made, buku bucks, but you made a little over $2,000, which is pretty good. Alright, and then we're done. So I want you to go work on your 8-3 homework for the rest of class. Also, your project is posted on Edmodo underneath this post, so if you want to get started on your quarter 2 project, that'd be a good idea. Make sure you behave yourselves for the sub, and I will see you tomorrow. Have a great day.